So finally, let's start from the module 4.1, which is all about the descriptive statistics. In this, what you guys are going to learn is to measure the center, how to measure the mean, median, mode, the spread, the ranges of the data, the IQR like interquartile ranges, variances, then as the standard deviation. You will use this information like percentiles, quartiles, visual summaries, how you will use these informations in the histograms, box plots. These things we will learn very precisely one by one. So stay with me. The learning objective of this class is first we'll learn how to summarize the distribution with the center and the spread, then how to interpret the percentile and quantiles, then we'll learn how to choose the appropriate values, visuals, specifically in terms of the histograms, box plot, what kind of visual we need to adapt for certain kind of data that you are working with, and then detect and reason about the outliers. When you're making the box plot, if you're detecting some kind of outlier, try to find out the reason behind it and then make a decision whether you want to remove this outlier or you would like to keep it in your data for the downstream analysis. So the first thing in this module is the data shapes and visuals. So distribution, actually you can see multiple type of distributions. One is the symmetric distribution, the second one is the skewed distribution. So symmetric distribution is when you are seeing a perfect normal distribution. When you're looking at the histogram, you are seeing the lower values at the left, lower values at the right, and perfect normal distribution. That can be sometimes a symmetric distribution. But then you see the skewed distribution. You see the multimodal type of distribution. You can use the histogram for the quantitative data. Whenever you are seeing any numerical values, numerical features, you can use the histogram and quickly visualize how the data look like, whether it is symmetrical, whether it is skewed or multimodal. You can use the box plots specifically to compare two groups, or bar plots or bar charts for the categorical count. If you don't have the numerical data, categorical data, then you can go for the counts, and we have already seen. Then we know about the center, spread, and shape. So in short, in very simple, these are the fundamental concepts in the descriptive statistics. What is the fundamental concept? First, you need to identify the center. Center can be anything. It can be mean, it can be median, and mode. So you need to learn about what is the difference between mean, median, and mode, in what circumstances, in what scenarios you should use either of these three values to find out the center. Then you go to the spread. Spread is all about the variability around the center. So for to find out the variability around the center, we need to understand the range in the data. Then we need to identify the interquartile range. Then we need to identify the standard deviation. Then you go to the shape. So this distribution characteristics like skewness, kurtosis, modality, if there is anything in the data, if it is not symmetric, you need to find out what kind of shape this data has. And then at last is the context. So context is the thing that drives the choice of somebody's statistics. So now when you have seen the data, you have seen the central values, spread, shape, everything you have seen. Now it would be easier for you to make the decision what kind of analysis you would like to do. So if you have a perfect symmetric normal distribution, you can mostly use the parametric test. Just for example, if you have asymmetric distributions or you're working with the multimodal type of data, you can go for the non-parametric type of distributions. So this can be your choice. So these contexts which we learn here actually drive the choice of summary statistics, choice of a statistical method that we are going to use for the downstream analysis. Now, how you measure the center? This is very, very important. Now, first thing is a mean that we discussed. So whenever you are getting a data, mean is simply you are trying to take an average. Think like this. Median is all about the 50th percentile, the data point which is covering the 50th percentile of the complete data. That is median. So it will not be always in the center. Okay, depending upon the data is skewed. If your data is skewed, I think you should not take the mean. Mean will not provide much information. In that case, you should go for the median, which is more robust to the outliers. When you have a skewed distribution, you have the more higher values at one end to the other, because then you are going to cover the 50th percentile in the data. Wherever it is covered, you will get the median value. Then you will get the mode. Mode is all about getting the most frequent value. So mode can be used for the categorical variable, numerical variable. When you are giving multiple values, it will try to identify which value is the most frequent, and that is your mode. So when you use for the symmetric or skewed data, you can choose what value, what central value you should use. For instance, mean is the average, you are simply computing, dividing by total, you're computing the range from start to end, and this is like sum all values and divide by the count. This is the simple rule for the mean. You're taking all the values that you have, you are making the count and dividing by the total instances you have in the data. And this is best when you are working with the symmetric type of data sets. Okay, then you go to the median. Now median is always good value to find out the center when you are not working with the symmetric data. You have the outliers, you have the skewed data. So middle value when ordered, it is resistant to the outliers and preferred for the skewed data. So median you can use if n is odd or if n is even. If n is odd, then you can simply use the summary of n plus 1 divided by 2. If n is even, then you can use the below formula. You don't need to learn these formulas specifically to compute the mean, mode, median. You will understand this is a simple one line command. If you will simply type your data frame dot describe, you will get everything, mean, mode, median. But this is just for your understanding, just for your sake, that which value you should choose, what kind of, how you infer it from the data, and which value will make more sense for the downstream data analysis. Then you go for the mode. Mode is again the most frequent value, and that can be anything. If you're just looking at your 100 or 1000 instances, there is a particular value that is coming again and again, so that can be your mode, maximum time that is coming. So may have multiple modes, useful for the categorical data and for the detecting the peak. So here you need to choose the right measure based on the data distribution and your analysis goals. After that, it's a measure of spread. Now measure of spread is also very important. So first you identify the range. How you identify the range is the minimum value that you will get in the data and the maximum value. So by subtracting the minimum from the maximum value, you will get a range. Then from this range, so I'm just doing it, simple measure of spread is the distance between minimum and maximum values, which is highly sensitive to the outliers. Okay, then you get the interquartile range. Why it is highly sensitive to the outlier? Because it can drag, the range can be dragged a lot. For instance, you have insert the range of values from, let's say, 10 to 100. This is your actual range, but you have one value that is outlier, and that value is 1000. So actual range you should get should be 90 if you are not considering the outlier, but the outlier is also a part of your data. Then the range you will get is 990, because you will subtract 1000 minus 10, but you are having only one data point for the 1000. So that's why we said that range is highly sensitive to the outlier. So you should be very careful when you should use range or when you should use the interquartile range. Interquartile range is not sensitive to outlier and can easily handle the outliers in your data. What you do here is, middle is the 50% of the data which is robust to outlier, used for the box plots and the outlier distribution. What do you do here? You get the third quartiles of the data, quartile third, and you get the first quartile of the data, that is 25% and 75%. So where is your 75% data and 25% data? And that's how you get the IQR, which is a middle 50% of the data lying between these two values, 25% and 75%. And from here you can define your outliers, and then you can decide whether you want to include them in your analysis or not. After that, you go for the variance and standard deviation. Again, if we'll go to the formula, that is too much for you guys, we'll simply learn few things here. The variance is, you are trying to identify the average squared deviations from the mean. Standard deviation returns in the original unit, and that you can identify by the standard methods. So ultimately you are trying to identify how much is the variance, how much is spread in the data, by taking the one value, subtracting the mean from there, doing the square, dividing by the total, and this part you are doing for all the instances, and that's how you compute the complete variance in the data. And then you go for the standard deviation. These variance and standard deviation along with the IQR helps you to make the box plots, helps you to make and identify the outliers that you can decide to, and on which you can take the further decisions. Now here we will discuss again what I was explaining to you, the percentile, quartiles and the box plots. So we were discussing something Q1, if you remember. So Q1 is the 25% of the data. Q3 is the 75% of the data. And then Q2 is our median, which is Q3 minus Q1, which is an interquartile range. Whenever you will see a box plot, you see this kind of plot in which you will see the center, which is our center value, mostly the median. You will see the top value, which is 75%, bottom value, which is 25% of the data, and then whatever is going up and down will be the outliers. So percentile partition data into the 100 parts, quartile at 25, 50, and 75 defines the IQR, define the boxes. Bix, whiskers extend the non-outlier range, and outliers can be identified by 1.5 multiplies by the IQR. You can easily identify these outliers and you can remove. Now, choosing the visuals is also very, very important in the descriptive analysis. When you will choose the histogram, when you will choose the box plot, when you will choose the bar plot, it depends a lot of what is your question, what you would like to explore, and the second is how, what kind of variable you are exploring. Histograms are good when you are working with the numerical variables, numerical data. It can quickly show you the distribution. It can quickly show you the symmetry in the data. It can quickly show you how well it is distributed across different bins. It will help you to identify the gaps in the datasets. Whereas box plot help you to identify and show the median, quartiles, and outliers. Excellent for comparing the multiple groups, and it is good for space efficient visualizations. So choosing the right visual is also very, very important. You can do the work examples if you want. You can simply take a data set, any data set. You can just define that data set as 2, 2, 3, 5, 8. You can get the sum of the values of the data set. You can compute the mean will be simple sum divided by total count. How, what is the count? 1, 2, 3, 4, 5. 20 divided by 5, so mean you will get the 4. So these are the simple practice that you can do in the Python, or simply you do the very regularly basis. Okay, if I will ask you what is the median of this data, so middle value at the position of n plus 1 is good, divided by 2. So the total n is 5. If you'll do 5 plus 1 divided by 2 is the third, so third value is the median value. What is the third value? If you'll go from here, 1, 2, and 3, so 3 is the median in this case. So this is how you compute the median. So you need to just remember these things, quick things in your mind, so that you get the information, the value that you are using for the centering, what information it is providing. Most is the most frequent value. What can be the mode here? Mode here is a 2, because 2 is the most frequent value, most frequently occurred here. So you need to decide whether you can use the mode, mean, mode, median, or in what circumstances. Now calculate the measure of the spread. How you will calculate the measure of spread? Measure of spread, you will calculate 8 minus 2, so the range will be 6. How you will calculate the variance? So for variance, you will go the x minus mean square divided by n. So this part you will do for all the instances that you have. 2 minus 4 divide 2 minus 4 square, 2 minus 4 square, 3 minus 4 square, 5 minus 4 square, 8 minus 4 square, divided by total n 5. If you will repeat this exercise, you will get the variance of 6.8. 6.8 is the variance in this particular dataset. How we will compute the standard deviation? By taking the square root of the variance. So standard deviation is 2.61. So now in this data set, very simple, in very simple practice, you understand how to calculate the mean, mode, median, how to get the range, how to get the variance, and then you will get the quartiles. So q1 for you here is the 2, q3 for you here is a 5, qr is q3 minus q1, and that will be 3. So that's how you get the quartiles and the interquartile range. Now the outliers impact and the detections. Impact on the statistics, first we understand. Strongly pull the mean towards the extreme value. I gave you the example. What if we will go here for the mean, and if we have a value right now, we are getting the mean of 4. If I would say I have a menu of value of 2 plus 2 plus 3 plus 5 plus 8 and plus 1000, so what I will get? My total value will be 1020. I will divide by 6. My mean will reach to the 200 or 250, somewhere around, but my most of the values are less than 10. So mean can be dragged super heavily by the outlier. So that's how, when you have the outlier in the data, mean is not a good number. It can inflate the standard deviation significantly. When you compute the variance, when you compute the standard deviation, it inflate the standard deviation also. It has a minimal effect on the medians and quartiles. So that's why In the box plot we use median. That's why in the box plot we use quartiles rather than using the mean. So that's why it's very very important. Median and quartiles are super robust and not sensitive to the outlier. This can reveal the meaningful insights or the data errors. Now, detection methods we have already discussed. IQR rule: value beyond 1.5 into IQR of from quartiles is the outside that whisker, and it can be considered as outlier. Z scores, typically Z greater than 3 standard deviations, can be considered as outlier. You can make some visuals, box plots, histograms, scatter plot, and you can quickly identify which data point is outlier in this context or this particular data. No universal rule, like how much value you should put as outlier. It depends on the context, it depends on the data set, it depends on what you would like to explore and how much that outlier can impact or inflate your data set, your data, which is most important for making the decisions. Now, coming to the practical applications in business analytics, you can monitor the KPI variability across different business segments. You can analyze the customer stratifications, score distributions. You can compare the regional performances with the box plot. You can use the descriptive stats to answer n number of questions in the business analytics. Okay. In the educational assessments, again, summary students performance across different metrics, take the improvement over time with the comparative statistics, identify the areas needing interventions using the percentiles. So you can use these descriptive stats to answer lot of questions in business analytics, data analytics. Use these quick box plots, bar plots, histograms, mean, mode, medians, standard deviations, variance, range, IQ, detect outliers, and use these information to answer some key question. Take one data set, apply these descriptive stats, and come up with something. What you have identified, what kind of outlier you have seen, what kind of treatment you can make for those kind of outliers. So those things you can do. Here the summary for you and the quick check is: remember, match center spread to the shape, report both centers and spread, interpret the percentiles carefully, visual the insights. This is also very very important. Choose the appropriate visuals, not just randomly jump on, like, I will make a box plot if box plot is not making sense. If you're just trying to identify the categorical data, how spread is their categorical data, so you will just go for the count, not for the box plot. Go for bar plots. If you have one variable, if you want to explore the data range with the specified width, with the specific gaps, then go for the histograms, not for the box plot. Consider outlier and their impact on the different statistics. Apply these concepts to the real world analytics task. Go to the Kaggle, download one dataset, apply all sort of descriptive stats that we have just discussed, that we have just learned. This is a homework for you guys before we go for the module 2 probability. You can do the quick summary plots, you can do the quick summary statistics, and report that. Make the notes, write it down, and share it with me, or share it with your colleagues. And I will see you in the module 2, in which we'll learn about the probability essentials.